Hello, welcome everyone. This video we're going to look at installing a native version of Python that will run on M1 Apple architecture, Apple Silicon, and we will install TensorFlow onto M1 computer that can run TensorFlow applications in the M1 GPU. So let's get into it without any further ado. I have a few. This is a brand new account on an M1 Air MacBook Air, and we're going to just open up these links that I have saved off. I wanted to talk about a few different things as we go through the process because it has been quite the process. And so I want to share a few things as I go through it. The first thing that I wanted to share was this open blog post from the Anaconda team about the transition to Apple Silicon and what it means for Python data scientists. It's a very good read, and I will include the links that I'm sharing in the notes of the video on YouTube. But what I wanted to do in the recording of the video is just point out a few things. If you go through this article, there's a point at which they talk about the different architectures and what that means. And then when you talk about, when it finally gets down to actually running Python on the M1, you can use the x86-64 Python distribution like Anaconda, but it will continue to use the Rosetta 2 translation layer. And that's what we did when we installed Miniconda in a prior video. It was actually using the Rosetta 2 translation for Intel architecture. The third option here is what we're going to do today. We're going to use the experimental Conda Forge distribution, which has been built for the new macOS ARM 64 architecture. So encourage you to read this to understand a little bit about why things are the way they are. Hopefully it will be interesting to you. The second link that I want to highlight is this one here. This is the Apple instructions for installing TensorFlow, and particularly the TensorFlow Metal pluggable device expansion. You can read more about this through this link. Again, the link to this page will be in the notes of the video. But we're going to go through this document in order to install Conda Forge onto this M1 device. I will just point out that there are a few other videos already on YouTube. I particularly like this channel from Jeff Heaton. But there are a number of other videos already on YouTube about installing TensorFlow on M1 MacBook. What I'm hoping to show in this video is just a from start to stop terminal screen. This is how it goes when you're installing TensorFlow. I have done this a few times already preparing for this video, and I'll talk about that as we get to it. So the first step is the requirements. You do need macOS 12. That is the latest version of the operating system, which until very recently was in beta, but it's macOS Monterey. I was when I first tried to do this, follow these steps, I was on version 11, and I was having a major issue that would not allow me to finish the well, I was able to install but not able to run TensorFlow applications successfully. And I'm going to include a link here to a GitHub issue where people describe the issue that I was having. Basically, trying to run a simple model to train the MNIST model, CNN. And what would happen is, instead of getting reasonable loss for each epoch, the loss was unreasonable. In fact, downright ridiculous, maxing out at 60,000 on each epoch. So under macOS version 11, this was the results I was having. And if you scroll all the way down, people talk about, upgrading to Monterey, and the issue is fixed. So either, through the beta program, people were able to install this and have it work, or recently Monterey was released, and now this can be run without issue. So that is the first requirement. The other thing is, again, noted here, multi-GPU support is not currently supported. Acceleration for Intel GPUs is not supported through this, obviously. And TensorFlow version 1 networks are not supported. So this is purely for TensorFlow version 2. Luckily, the installation instructions are actually pretty straightforward. Obviously, because we're using Apple Silicon, we will need the ARM64. And there's a link here, which if you look at the link, it's a GitHub link to the CondaForge project and the Miniforge repository to download a shell script that will do the installation. I took it upon myself to dig up the repo here. If you wanted to look at the different releases, you could do that by clicking on the releases link on their repo page. So again, I'll include all 5 of these links in the video description if you wanted to come look at this. One thing to note here is already they have in their download table, they have a ARM64 Apple Silicon download with the triple asterisks here. Apple Silicon builds are experimental and haven't had testing like the other platforms. I think it is suffice to say, when you download this, you're using the Apple Silicon version at your own risk. Using the x86-64 version of Python is the safe bet right now if you need anything for production or anything like that. If you're just messing around and seeing what the Apple Silicon can do, feel free to download this. Jeff Heaton has both Miniconda x86 installed and the CondaForge ARM version of CondaForge installed, and he talks about switching between the two. So if you're interested in something like that, go look at his videos. I think he was going to release a video about how to set that up. So having gone through the requirements and the the provisos, the warnings, what we'll do is we're going to download this. It's going to prompt you to allow that. And then it downloads pretty quickly. So I'll just go ahead and open up a terminal. Make this a little bigger. And then head over to the downloads folder and list out what we got in there. So we have one file in there, that's our download, and it has finished. It was only about 40 megabytes. May take longer depending on your connection. And so what we're going to do is we're going to chmod it to allow execution. And if we look at that, you can see now it is allowed to execute. So we're going to run that shell script. Okay, so you get the welcome message here, and it's going to step you through the installation process. So review the license agreement. You must review the license agreement. Make sure that you are approving of the license. Do you accept the license? Yes. It will then ask you where you want to install it. I'm just going to install in the default location. You can specify your own location if you want. I am going to specify default, and it will start unpacking and installing this. It'll take a little while here. Once it's finished installing, it'll ask, do you want to initialize Miniforge by running conda init? I do. It's up to you if you do or not. I do. Typically, I do it in PowerShell. I have done it before in regular or Intel versions of Python. And it's now installed. I'm going to shut the shell, close and reopen the shell. And now you can see the base environment is activated. So that lets me know that everything was installed. You can also look at the environment list to see that it's there. Next, I'm going to create an environment. I'm just going to call it TF M1 for TensorFlow M1. And I'm going to give it a 3.9 version of Python. And it'll take a little while to create. So just give it the yes, and then it will download everything and install it. I like getting into the habit of creating environments for my projects. The base environment stays clean. All right, so now if we look at that environment, it has a few things in it, the basics. This source activate, I believe, is to activate the environment if you were not going to use the conda activate. I'm using conda activate. I don't see the need for this. I don't understand why Apple included it. I have gone through this process a few times, and it's worked without activating it with that command. So I leave it up to your discretion and your research to find out if this is required or what. But I'm going to keep going forward with the next command, which is installing the TensorFlow dependencies from the Apple channel. This is interesting. So you're using the Apple channel to install TensorFlow dependencies. There's some instructions here while this is happening in the background. There's some instructions here about uninstalling if you're to go through the upgrade process. You may want to do this. You may want to just close down the environment, the conda environment, remove it, and then create a new conda environment for a new version of TensorFlow. I've even, in some cases, gotten into the habit of putting the version number in my conda environment name. It's up to you how you manage that. It also allows you to use different versions of the dependencies. So if you wanted to stick to version 2.5, you could do that. The current version as of recording is 2.6, as far as I understand. TensorFlow. So it's up to you. It seems like the dependencies and the Mac OS version are in step at the moment. So after this is done, which it is, the dependencies, then you install the Mac OS version of TensorFlow using Python-m pip. I won't tempt fate just by using pip alone, but this should work just fine. And it's going to download the TensorFlow version of macOS. And you can see it's version 2.6.0 for Python 3.9, macOS 11. I don't know why it didn't update to 12, but it should be fine. And then the architecture here, ARM64. It's nice that it's a wheel. And then the third step will be installing TensorFlow Metal. We'll do that. Once this is done, so that looks like it's fine. Installed TensorFlow macOS 2.6. So we'll pip install TensorFlow Metal. This is for the GPU. That is currently at, as of time of recording, 0.2.0. So just for reference, this is in, well, the 1st of November. So just be aware versions will change over time. So if you're installing 6 months in the future, you may be looking at different versions. That is it. There's nothing else. It's installed. You're ready to go. So if we look at Python version, it should be 3.9. If we go into Python and import TensorFlow as TF, the TF version, oops, should be 2.6. Takes a little second here for this to build everything. 2.6, and then I think it's config. I can't remember the function. Anybody see it? I'd ask you to call it out, but I think it's one of these. List physical, I think, is the one that we're looking for. Yeah, so it recognizes the CPU, it recognizes the GPU. You may often see, or you may see it something like this, where they actually put the GPU string here, and then it just returns a list of physical devices that have device type GPU. The moment there's just the one index 0 GPU. So that's good. It means that it's recognizing our GPU. What we can then do is go to the public folder, and then the Dropbox. Like I said, this is brand new account. So in order to get some files that we can validate the installation, I dropped these into the Dropbox. So let's do TensorFlow MNIST Atom. So we'll run Python tf MNIST Atom, and it's just going to run a training on a simple MNIST CNN network to train a network to recognize handwritten numbers. And you can see the loss here. What we can also do is open up Activity Monitor, and you can see the GPU working, hopefully. Yeah, So the GPU is working here. So it looks like something stalled out. Did I freak out the GPU? Looks like Python has dropped. Oh, the screen recorder is using the GPU. Well, let's try stopping the screen recording for a second and see how it goes. Okay, started the screen recording again, and you can see it just finished after I had to close out the terminal and reopen it and train it again without the screen recording going. So perhaps there was something happening, a conflict between the screen recorder and the TensorFlow program. It got stuck, I think, last time in Epoch 4, but the next time through it was able to run all the way through. Let's just see if it happens again. If we run SGD, let's see if the screen recording impacts this program. Oh, I haven't installed sklearn. Let's try RMS. Right. So yeah, I had downloaded these simple MNIST networks previously, put them into Python files for this, just testing the GPU. You can see down in the bottom left-hand corner of the activity monitor, you can see the GPU is being utilized. This was the first tall set of bars was when it was training the Atom optimizer, and this one is what did I say? RMS prop. Yes. So far it's working. You can see the loss in the accuracy is much more in line with what we're expecting. This one was just 5 epochs and then a validation set. So you can see it got up to 99% accuracy, and then the validation set 98.5, and then it was done. So in that case, the screen recording worked fine. We had been recording for, I don't know, 20 minutes or so before we started the first training. So it's possible that the recording as a whole played a part in issues with the training of the network. Current memory pressure is really low. So yeah, the MNIST data set is not huge, so I wasn't expecting it to having a lot of pressure. But anyway, that's that. So in summary, the steps for installing Python for ARM64 is pretty simple, right here. And then installing TensorFlow dependencies and TensorFlow itself for macOS, and then TensorFlow Metal plugin, relatively simple. The key component I missed in the earliest portion was you do need to be on macOS 12 Monterey. So if you haven't upgraded to this, make sure you are. The other tip I would have if you are running into any other issues is to come over to the GitHub and read through the issues posted in the GitHub. Seems to be where people are posting their issues that they're running into, and you can find code for simple networks that you can train just to validate that it's using the GPU. So that's it, my friends. Just a quick video, hopefully around about 25 minutes, showing how to install and then running a simple network showing the GPU being utilized. Again, please head over to my friends, not my real friends, but my virtual friends on YouTube and watch their videos as well. All right, have a good day.